Welcome to the Shuswap Launchpreneur Business Competition. We want to thank first our sponsors for their generous support of this program. This video will cover the topic of product and service development. This is the first part of your business plan and is critical to your success. The presentation by Steve Karkner in this video will talk primarily about product development. It is important to note that many of the things he talks about in the video that relate to products also relate directly to services. Should you have any questions about how to apply this knowledge to your service, please feel free to contact your site's mentor for more information. Each of the tasks of this competition relates to different sections of the business plan. This first task will deal with the product and services section of your business plan. This section has two main key parts: the product and services description and a description of your competitors. Product or services section will answer a number of questions for potential investors. This section needs to clearly communicate all the relevant information that an investor, lender, or participant in the business will need to know in order to successfully understand your idea. Regardless of whether you're going to be selling a product or service, this section of your business plan is critical because it answers the question, what are you going to sell? You can't assume that the person reading this has any knowledge about your product, service, or the industry that you're going to be competing in. As such, you need to explain to them a bit of the history of this type of product. If I were to be selling cars, I would want to talk a little bit about the history of cars, taking them from 100 years ago to today. This will help to give them a context in which to understand your product or service. I would want to talk about the features or characteristics. I'd also want to talk about the benefits. Remember, benefits are going to be customer focused. What does your customer see the benefit in this product? What needs does it meet for them? This will also help you to identify what business you're really in. Price. You should include a price list and pricing strategy. Are you going for penetration pricing to get into the marketplace? Or are you going to go for premium pricing, looking to sell prestige and quality of your product? Included with that, you need to include a rationale for your pricing strategy. You need to talk about why this strategy makes sense for your product and for your customers. It is very important that you talk about what makes your product or service unique. Talk about its competitive advantages. Talk about why your product is different from the other options that are out there. Is it faster? Is it better? Is it stronger? Does it last longer? You need to really look at what makes your product special or different from your competitors. You should also include a brief statement about how customers will access your product or service. For example, retail, direct sales, internet mail order, etc. But keep it brief, a sentence or two, because it will be covered in greater depth later on. You also should talk about the stage of development of your product or service. Is your product needing to be prototyped? Is it needing to be gone through alpha and beta testing? If it's a service, do you need to get licensing? Do you need to get training first? Also, you should look at the proprietary information. Does your product or service need or have patents, copyrights, trademarks, or a registered name? The second section, your competitors, is a description of the existing products or services which are either direct competition or are substitutes for your product or service. The section on your competitors should answer the following questions. Your potential competitors, including details of their strengths and weaknesses, for example, price, characteristics of the product or service, whether the business is steady, increasing, or decreasing. Key direct competitors should be considered individually and evaluated by their strengths and weaknesses. This is important because it will inspire investors with confidence in your product or service. Indirect competitors can likely be summarized as groups by their strengths and weaknesses, with a list of them included in the appendix if they're significant in number. Make it clear you have a good understanding of the competitive climate. You will need to explain the weaknesses and market gaps you identified in this competitive analysis. A description of the market niche that you are seeking to fill with your product or service is critical to inspire investors with the confidence to support your product or service and your business. You also need to explain how your business will capitalize on these gaps. It's one thing to identify a gap, it's another thing to say how your product or service uniquely meets that need. The information you research in the competitor section should tie directly into a later presentation on marketing, which will look at how you will promote your product compared to your competitors. So please keep these topics in mind as you work on your product or service section of your business plan. And as you watch the following part of this video, hopefully you'll be able to see some useful information that will help you in preparing your business plan.
Good evening, ladies and gentlemen. Welcome back to CIBC Presents Entrepreneurship 101. Two things to say. Lest you think that we love you so much, we've upgraded to this, and I've mentioned this to our speaker, this is all for Samsung. I don't have that much sway here. Apparently there's some big product launch or something going on. That's why the fancy white gauze drapes and all that. Just ignore that, okay? The other thing, I have threatened in the past that Mars was launching a new website and there was going to be all sorts of fantastic material. Well, it's actually happened. And there is a whole entrepreneurship training and education section with all sorts of modules and workbooks, and I encourage you to go there and check that out. There is material being added on a regular basis, and what we're going to do when we get our act together is at the end of each lecture we'll tack on a slide that points you to the relevant follow-up supplemental workbooks and all that. So when you go online to check things out, you'll be able to follow that up. The website was just launched a week ago. Haven't quite got there yet, but I do encourage you to use that. It's designed to be an online resource, self-teaching, that'll help you build on what you get here. So, tonight's lecture, Product Development. I am truly delighted to welcome back Steve Karkner from Panesis Inc. Still Inc.? Yes. Steve was here last year lecturing on this topic, and the bio that we posted that we got from Steve is characteristically modest, so we dug a little deeper. And one of the key things to tell you that Steve was Director of Product Development at Research in Motion. And he was there when that company grew from a 12-person consulting company into a multi-billion-dollar wireless company. There's a number of patents of RIMS that he holds, and several dozen patents worldwide. And he was part of the marketing and biz dev, so that's a pretty stellar experience to have. He is the founder of Panesis, which is a shop that works on working with, I think, both your own ideas and other people's ideas and really turning them into real products. And I can tell you, he's worked with a number of university groups who have developed, sort of a lab prototype, and he's partnered with them to really take that to a real product that goes to the market, as well as a pretty broad spectrum of companies, similar roles to play. So we could think of no one better to bring here from Ottawa to talk about product development. And I should mention he had quite a challenge getting here, and involves planes with frozen wheels and attempting to break them free of ice. And so he has had his share of trials and tribulations getting here, for which we thank him. So, Steve, over to you.
Thanks. Welcome, everybody. It's good to be here. And I guess as a lead-in, what am I going to be talking about today? Product development's kind of broad. And this is maybe not the most exciting presentation. It's a very nuts and bolts presentation, because ultimately, I guess we're dealing with nuts and bolts. We're dealing with, when you have an idea, how do you get that thing into a product or into a service? A lot of this stuff is applicable to services. How do you get it into a product? But even more than that, you all know there's a lot more to business than just a product. There's all the financing and all the other marketing business stuff that goes on behind it. The better the job you do demonstrating that you are ready to deliver your product, the more you demonstrate that you are able to actually follow through with your promises, the more likely you are to get funded. The more likely you are to have everything else in your business kind of come together. It's not that this is the only thing, it's that you put everything together, right? Without the financing, you don't have a product. Without the product, you don't have the financing. It all goes together. So the focus today is, how do you take that idea, document what it is that you're trying to do. Documentation, it's always boring, but document what you want to do, and then actually get it done. That's what my focus is today. Okay? So, and if you have questions in the middle, if they're really important, stop me. If not, I am going to be here afterwards. Lots of question and answer. I'll stick around afterwards, so whatever questions you have, I'll stay until they're all answered. Okay? So, about me. So a 20-year product development experience, and as I'm maybe not as modest as I was last year. So I'm an award-winning product designer. You can actually see my products in Popular Science. They've been in there a couple times, Museum of Science and Technology, stuff like that. And yes, I'm the founder and president of Panasys Incorporated. And I'm also an investor in a number of startup companies, an advisor to a number of them, and try and kind of watch what's happening in a few different companies. And I love startups. I'm not such a fan of the big companies. I like to grow them. And the rest you've already heard of. So, what is Panasys? Panasys is a little more confusing. We are a medical, military, and industrial product design company. And we call ourselves a co-development company. So most of the work we do is where companies come to us with an idea, usually a marketing plan, but that's about it. And we'll help define the product, maybe do a feasibility study, make the product real. Quite often we actually manufacture it in-house. We'll even sell it and do all the aftermarket support. Small stuff. We haven't got too many products that have gone into the millions of pieces yet, but we're getting there. And we especially like to get involved in the high margin stuff. We do a lot of work internationally, and we do a really wide variety. Hold on a sec. We do a really wide variety of sizes. So, for example, little tiny novelty lights. We do this silly little light that goes in a cooler that sells at Walmart. Silly, but it actually sells really well. Right up to power systems in fighter jets, aircraft carriers, and even powering artificial hearts. So there's quite a span. And it doesn't matter how big or small they are. They all need the same stuff. They all need the same documentation and plan behind them. It varies in terms of size, but you still need to have the steps. Finally, Panasys is a profitable high-growth company. We were actually on the Canadian Profit 100 last year, ranked a couple steps behind RIM, but maybe this year we'll beat them. We'll see. And so far, so good. So that's it. That's the shameless self-promotion. Here we go. Have to do that, otherwise, it's hard to justify the plane ticket. So, product development path. As I said, size shouldn't matter. What you're doing should not change the path. It only changes how much documentation and how much, perhaps how much effort you put behind it. Fundamentally, failure to have a detailed plan for your product, at the very worst, it will lead to inefficiency. It will lead to products that don't quite meet the mark, a lot of spin. It could lead to complete failure. It could lead to a product that either doesn't work or complete failure from a marketing point of view, or just doesn't address the market and doesn't sell. The worst case, though, is a lawsuit. And that's kind of scary, but you know, if your product is really off the mark, or maybe your product never gets delivered, you could actually get negative. You could be facing something like that. So following a plan, having a plan, following the plan, it will dramatically improve your chances of success and of not just delivering, but delivering a product that is going to go big. So one of the changes I made to the presentation this year was I've added in an example. Last year I kind of gave examples as I went, all different examples. I'm going to try and focus this year on one example. So the example is a flashlight, because oh my god, a flashlight, how simple, right? How could you even need a development plan? That's what we're going to take a look at. So when you think about how to chart your development, and again, it's all about the number of zeros. Flashlight development plan has fewer zeros than developing, say, a ship. But let's take a look at how we develop it. I'm going to talk about the V model of development in this presentation. There are lots of different methods, lots of different models out there. They all have advantages and disadvantages. I personally like the V model, so we'll go through that. This slide's a little mucked up, but it'll work. You start down, there's no laser here. You start up there at the top and you come down to the bottom, and then you go back up the top. And as you come down through concept of operations is the top one, requirements and architecture of the product, detailed design, then you implement it at the bottom. And then you go up the other side, integration, test and verification, system verification, operations and maintenance. And I'm going to describe all of these in detail. But you notice a big yellow arrow going across. That's sort of where you pause each time and you check back against the other side of the plan. The funny thing about the V model is most people, when they first think about developing a product, they think the bottom, implementation. They think that's the whole plan, right? They think that's where you're going to spend all your time and all your money. The fact is, that's actually a very small part of it. You should be spending about equal amounts of money and equal amounts of time on both sides of that V. Not just at the bottom, not just on one side. Developing a product, having a prototype does not mean you're done. Having a prototype probably means you're not even halfway there. So what is concept of operations? Principally, it is the idea of what is your company, what are you trying to do? So looking at who wants it, the product. Well, Walmart, Road Warriors, stocking stuffers, going back to that flashlight idea. What is it for? Well, is that flashlight for serious lighting applications, or is it just for fun? Is it just a little throwaway product? Who's going to pay for it? Consumers? Is it an industrial product? Is it a government product? What is your capability? Your capability as a company. Are you a distributor? In which case you might as well just buy something in and resell it. Are you a designer? Do you want to be a manufacturer? Do you want to be all three? You could be all three. So you need to start narrowing it down, and all of a sudden something as simple as a flashlight becomes maybe a little more something to think about. One thing I want to correct is Walmart is not who wants it. Take them right off the list. Walmart is not a customer. Unless you're selling them a safety flashlight that they're going to install in their stores, Walmart is not a customer. And I actually hear that type of thing a lot. I'm going to build a product and Walmart's going to buy it. Walmart doesn't buy it. Walmart customers buy it. So let's narrow it down a little more. Let's pick an idea here. So let's say that the flashlight is for road warriors. Let's say it's for serious lighting. Let's say then that it's for a consumer. And let's say that we want to be the designer of it. So now you're starting to focus, you're starting to figure out what the heck it is you want to build. So we're going to build a flashlight for road warriors to use in serious lighting situations. It'll be bought by the consumer. We'll design the product and outsource the distribution and manufacturing. Note, cheaper is not a viable business model. And this is a product development presentation. I'm not going to go too much into the whole business strategy side, but it is something to keep in mind. Again, something I hear an awful lot. Oh, I've got an idea for something cheaper. So what? It's really hard to get into the market with cheaper. You need different, better, a focus. So that's where that stuff at the top comes from. The next thing on the V model was to get into the requirements and architecture. So this is where you start to get a little more into going down that whole side. You get into what is it the customer wants? What are the market requirements? That document should not be technical. That document should be, what do they want? What would you put if you were selling this thing and you were coming up with your ad? What would you put in it essentially? The next thing is your functional requirements. You can get a little more technical. But again, it shouldn't be really more technical than what you would normally see on maybe the back of the marketing plan. You know, you go onto FutureShop's website and you're looking up a product. The front page tells you a bit about what the product does. Then you click on specifications and it gives you a whole bunch of other stuff. That's maybe what belongs in the functional requirements. Next step down is your product engineering spec. Very technical. Now you're saying exactly what is it doing, exactly how is it doing it. That's the time where you get the engineers involved. Engineers probably shouldn't even be involved in the first two. The last document you need is your test and verification spec. This is where you're saying, okay, you know what, I know my engineering spec, but how do I test it? And again, I'm going to break these down in a little more detail. It's really important to work on these sequentially, to work on them in detail and to get them right before you move on. And the reason is that correcting a mistake is very costly the further down you go, especially if you've actually launched and started designing something and then you find out you messed something up. So important to do them one at a time, or at least not get too far into the next one. So let's look at the flashlight again. So looking at the customer market requirements. We don't want to be technical. So it's for a road warrior. We want it to be durable and light. I don't care how durable, I don't care how light. I just know it's got to be durable and light. I can worry about the technical part later. Bright, even light. These road warriors, they want it to be functional. It's not a toy. If it's a toy, you don't care. This is not a toy. So bright, even light, good battery life, serious situations. It's a road warrior. We don't want to ever leave them without a light. If your product gets a reputation for leaving them without light, they're not going to buy it. And price, hopefully, is only moderate consideration in this case. And these, I'm just throwing these out as examples, of course, for the flashlight. Every product, every service is going to have a different list. And this is a good place to talk about what makes the product special. Because again, if you're going to market, if there's already 10 flashlights out there for the road warrior, well, so what? What are you doing that's special? So maybe this is a good place to say, I want it to be the smallest. Again, don't say how small, don't limit it yet, don't get into technical, just I want it the smallest, or I want it the lightest, or the brightest. Leave it to the engineers to figure out how to achieve that goal. You might want to do the competitive comparisons here, probably should. So if the competition is Maglite, for example, great. Say, here's a Maglite, here's the specifications for it. I want to beat these three. Great. And try not to pick cheaper. Now we get into functional requirements, your next document. And by the way, I say next document, but depending on the product size, it may not actually be a separate document. It could be a separate section or something like that. I've seen product specs that have the customer requirements, the functional spec, the technical spec, all in 4 or 5 pages. This doesn't have to be hugely onerous, but making sure you've got it documented is extremely useful. You'll come back to it again and again. So functional requirements. How lightweight? So a good example, you know, how lightweight? Well, it'd be nice if it was less than 50 grams, but let's try and hit 40. And the question is, why? most of these functional requirements should have a why. So why less than 50? Well, it turns out Maglite makes a nice little Road Warrior light that's 49.6. So you know what? 50 were level, 40 were the lightest. So okay, give us the reason why so we understand what's the priority. How bright, adjustability, long life, I don't know. You can start putting numbers on all this stuff. What kind of drop, what kind of shock, what kind of waterproofing, dust proofing. Outline everything that defines the product here. And all of these should relate back to the customer need. If the customer doesn't really care, if the customer wants it durable, you need drop, shock, all those things. If the customer doesn't care about it, like it's a Road Warrior, do you really need water resistance? Don't throw in stuff just because. There should always be a reason why for all of these. Extra features could be added here. If they weren't envisioned in that customer support, again, say why. So the extra bulb's a good idea, right? You could say, hey, let's add an extra light bulb. Why? Well, because that way the guy's never left without light. By the way, Maglites all have extra light bulbs. Surprising how many people don't know that. It's in the base. You know, it's a feature they add, and most people don't even know about it. So it's a good place to add extra features. The product engineering spec. So now we are going to answer how. So we've said, I want this thing to be, well, there we go. So I want this thing to be the lightest possible. So maybe we say, okay, let's use AAA batteries. You know, the other flashlight vendors, they're all using AA batteries. We're going to use AAAs. AAAs are smaller and lighter, but we still want battery life. Okay, well, to get the battery life, we'll use LED technologies. So now you're really defining exactly how you're going to meet the goals. And again, defining more stuff. You know, here's our mechanical design. Our mechanical design is going to have seals in it. The seals are going to meet the waterproofing. So getting very, very technical. And what goes along with that specification is your test and verification spec. So this is where you say, how am I going to prove it? It's all well and good to say that the thing is going to have a 4-hour battery life. This is where you define, how do I test it? That's a pretty easy one. I'm going to turn it on and, time it. But some of them are not so easy. Things like lightning proofing, for example. How do you generate lightning? I've actually seen test setups for that. It's pretty cool. Yeah, and we really want to focus on what the design does. Does it do what we expected? Ideally, this is something that you only really do on the first products, the prototypes, essentially. You're not really looking at something that's going to be done in production. So these can be very long, laborious. They can result in long documents. That's fine. What you find, though, is when these are written well, not only will you catch any design failures before you get too far down the road, but this will actually feed into production plans later. So what will happen is you'll go through it later and you'll say, wow, these tests were really easy to carry out. We're going to put those in our production plan, and maybe we do those on 100% of our products coming off the line. So doing this well not only proves the design, but it actually can be used to increase your quality later. Detailed design. This is, we're finally into the detailed design parts, the implementation part. And this is what most people focus on when they think about a product. They kind of jump right to that detailed design. Hey, I know what I want here. It's a sketch. Build it. It's taken you a while to get here, but at least by the time you get here now, you actually know exactly what you're doing, why you're doing it, and you have a good idea of how. This is a great opportunity to outsource, because certain elements of the design are always going to be better done by somebody else. Look and feel is a good example. Mechanical engineers are very good at doing mechanical designs, but they're often quite bad at making stuff look good. There's another group, they're called industrial designers. Great at making stuff look good. Oh, gorgeous looking stuff. Quite often you can't build it. Looks good, can't build it. So, you get those guys together, you start refining what it looks like, you give it to your mechanical engineer. You may want to outsource that. One of the difficulties with getting really good product design done is you don't need those resources for very long. So pick a good one. I'll go into that a little later. Pick a good one, spend the money, get it done right the first time, and hopefully you'll be done with them. And then you can move on. What you want in-house is whatever you identified way back in your concept of operations. When you asked yourself, what is my company? What are you guys good at? What's your focus? In large projects, large products, there's going to be some certain things you're really good at. Maybe you're good at, I don't know, at some networking switch and you're really good at algorithms that increase the speed of communication. Great, hire up lots of staff to work on the speed of communication. Don't worry about hiring mechanical engineers to design the housing. It's not your specialty. There's other people way better. So it's my approach anyway. It might not be the best approach. So far so good though, it seems to be working. All the time going through the detailed design, keep looking back at that customer requirements. And if you're the manager, it's actually your job to kind of look down and make sure they're following that customer requirement, make sure they're not getting kicked off into the weeds. Biggest way people get kicked off into the weeds is not missing the customer requirement, it's going way beyond the customer requirement. It's called feature creep. Feature creep will kill many projects. The engineers, they love to just throw in one more feature, one more feature. Oh, but we could just do this. We could just make it a little faster, a little lighter. And before you know it, the product is 10 times more expensive and way over budget. And you know, you don't even have a prototype and the trade show is 2 weeks ago. So feature creep, that's your job, is to look down and make sure it doesn't happen. How do you do it? You have your customer requirements and you've defined what the product should do. And that gives you the ammo to keep it on track and to keep focused. So now we build it. We've designed it, now we're going to build it. So depending on the size of it, you may want to break it into smaller, easier to manage pieces. So if it's a really big thing, and big could mean, you know, software big. If it's big, you break it into smaller pieces, give it to people who know what they're doing. That includes the actual building of the product. You could have several subcontractors build individual pieces and then bring it back into one assembler, or you could have one assembler actually do all the subcontracting for you. Either way works. Make sure, though, that for any contractor that you create a really clear statement of work. That statement of work says exactly what you expect from them. It's fair to both parties. It's not fair to hire somebody to, say, you know, build a piece of your product, and then you say, yeah, but you know, there's still some little problems. Can you just correct those on the way? That's not fair. You know, make sure the statement of work clearly says what they're going to do and what they're going to work from, and how to handle problems, because there's always going to be problems. Whose responsibility is it to handle the problems and to pay for the problems? So a good statement of work will help you deal with the contractor. And finally, make sure that any departure from the specifications come back. The feature creep, as I mentioned before, anything that they find that's unexpected, that doesn't work properly, make sure that it goes into the statement of work. Make sure that it actually gets all the way back into the customer requirements. So this is where, you know, somebody's trying to build that flashlight, say, and they find out that the water seal, every 10th unit they put together, the water seal gets pinched and broken. Well, you can either deal with a 10% failure, or get it back, find out where things went wrong. Maybe it was back in the engineering documentation, maybe it was in the mechanical, whatever. Make sure it feeds back. Quite often you run into these products where they actually are getting a really crappy yield, and the contract manufacturer, they just increase their price. And you don't realize that now you're actually wasting money and you're blowing all your profits, and you don't realize that actually it's just some stupid little thing that you could have fixed if only they had told you about it. So make sure to keep the feedback. Some tactics on tracking, and this is just a really simple one, and we use this one today. It works well. Spreadsheets are fine. Don't be afraid of them. This is a little Excel spreadsheet. There's lots and lots of tools out there for tracking bugs, and we have some that work over the internet and things like that. But I still like the spreadsheets. So just to give you an idea of how we work these, this is a spreadsheet that anybody can add to, employee or customer. Anybody can add to this. And we just keep track if anything's reported. So over there, description, customer specification does not explain what charge enable signal is used for. If it can be ignored, we plan to ignore it. And then, a little further along, you come over here, how to fix it. Well, it's being clarified, the signal's an absolute requirement, second processor added to the design to handle it. And we close it off and it's done. This is really useful. It's surprising how often, especially on projects that go over a year or two, how often little niggly things get forgotten. Way back in the sands of time. You throw them on here as soon as they're identified, you throw them in a spreadsheet, you throw them in a database, web portal, whatever it is you've got. Throw them on here, and they don't get marked closed until they're truly closed. And even the littlest thing won't get ignored. And your customers, like this blows our customers away. They don't see this. What our customers know is, wow, those guys never seem to miss a trick. I told them something 6 months ago, and when the next revision came out, it was in there. And they're surprised that we don't seem to forget anything. And this is why. It's not our brains, it's these stupid little spreadsheets that hang around. And so at the end, before we build the next revision of anything, we go through and we either make sure they're all closed, or we make sure that we understand why they're open, and we say, well, yeah, too bad it's not getting in this revision. Yeah, so little spreadsheets, they help us keep track. So now we're coming up the other side of the V. So you've got prototypes. A lot of people think you're done. Run into that all the time. Hey, we're done. No, we're not done. We're halfway there. In both time and money, we're only halfway there. And that assumes that you don't actually run into problems. If you run into problems, who knows? All bets are off. So, yeah, so I just mentioned the first two, I guess. So this is where you start with the final product, integrating it into whatever the final environment is. And some products don't really have an integration step. You'll notice I'm starting to depart now from the flashlight because it doesn't fit that well into this. Flashlight, hopefully, is a single unit that doesn't integrate. But it could integrate. If that flashlight, for example, was for a soldier to carry, does that flashlight fit in the pocket on the soldier's uniform? Sounds really obvious, right? You'd be surprised how often it goes wrong. In fact, I know that particular one went wrong. I've seen the example of it. I've seen soldier systems where the jackets came out and they didn't fit the ammo. It happens. And I actually have another example of that coming along here. So it won't work the first time. Never does. Sorry, never does. I don't hire us. It still won't work the first time. Never does. Not perfectly anyway. And it doesn't necessarily mean technically it doesn't work. Quite often it means customer-wise it doesn't work. You give it to the customer and you say, here's what you wanted, and they look at it and go, it's not quite what I wanted. And you go back and you fix it. And that's the most expensive error, by the way. When that happens, I'd almost rather it be a technical thing. So most of the time, ties back into technical. It's really bad when it ties back into the customer spec, because boy, have you missed the mark at that point. Resist the temptation to just quickly modify on the fly. If you've gotten to this stage and you've got a product that kind of works, try and go with it as much as you can. If you revise on the fly, you say, we can just fix that, and you just fix that, and you come out and you show it to your customer, and the customer says, oh, that's a little closer. Oh, shoot. So you go back and you revise it on the fly and you fix that little thing and they say, oh, it's a little closer. Now you're in real trouble. So if it's working kinda, keep it in your customer's hands or in your marketing guy's hands, or keep it out there as long as you can before you go to the next step, and take all of that feedback all at once and implement it all at once. Come out with a better product all at once. Much better approach. If you've got the time, if you can do it, just hold off as long as you can. And you may still have to go through multiple iterations, but at least the iterations are bigger steps instead of a whole bunch of little tiny ones that just kill you. And ultimately make sure that everything feeds back and gets documented in the statements of work and the specifications, and right back to the customer spec if necessary, because otherwise you get down the road and suddenly you don't know what you're testing to anymore. Now you get into the system verification and validation. So now, you know, your customer's seen it, your marketing guys have seen it, it looks pretty good. Now let's get it out in the real world. So if this is, for example, we do battery systems for aircraft, this is where now, you know, it's worked on the bench, the military guys have seen it, yeah, it's light enough, everything's good. Now you actually put it into the aircraft and you try it out in the aircraft. And this is where you find out that what the customer told you about their product, about what you're integrating into, this is where you find out that they were wrong. And again, it's very costly. So the customer in this case, they thought they knew what they wanted, but they told you wrong. And they told you wrong usually on a technical level. Another good example would be like bandwidth. You know, some customer says that they're looking for a new network link or something to their office, and they say, I need 10 gigabits per second, and you install 10 gigabits per second, and they say, oh shit, we're still off by a factor of 10. You know, they didn't measure, they didn't do whatever. So that's where actually having technical salespeople at the front end really helps, because the technical salespeople can look at what your customers are telling you and validate, make sure the customer actually knows what they're talking about. And this is where you have as well the unexpected interactions between devices. So you built something, somebody else built something, somebody else built something, and you plug them all together and you find out that there's some weird little interaction. A lot of this stuff you can't predict, but you can budget for it. And that's why I was saying, when you look at that development process and you look at your development budgets and you think about how much it's going to cost to develop the product, you're halfway there. When you develop the product, you're halfway there. This is the other half. This is the half that's always forgotten. So the other thing with the system verification and validation plan is to understand that every item should be checked. Don't just be content to show something to your customer, to have the customer, you know, plug it in and try it out and say it's pretty good. Make sure that every single thing is checked, because there's usually a reason why each individual line item is in there, and it's very easy to jump over them. So if you write that system verification plan properly and you catch every single one of those, it'll help you out a lot. And we see these things called verification matrices used a lot here, where when you use your specifications are often written, you know, with numbered paragraphs, right? Almost everybody uses that. Outline numbering, that's what outline numbering. So every line in your specification has a number associated with it. Throw it into a matrix. Nice Excel graph or database or something like that that actually says, this is line number 6, paragraph number 6 said it must do this. Next column, how did you test it? And did it pass? And it's amazing how often you go through that matrix and you find out that out of the 450 things it was meant to do, there were 2 it didn't, that easily can get missed. So you do up a matrix, you go back, and this again is where having those good, clear documents actually makes it easier to make sure the thing works. If you're selling to a customer as well, that is what is going to protect you from not getting paid. Very important. If you can show that and say, we both agreed that this was what the product would do, and the product does exactly what we agreed to. Now, yes, you maybe both agree that it doesn't quite meet the mark in terms of what it needs to do in the real world, but the dialogue will be far friendlier, because whoever you're working with is much more likely to say, yeah, you know what, you're right. I'll give you more money for that, or I'll help you cover the development costs, or I'll give you more time, and all of a sudden it becomes a friendlier exchange, as opposed to going, I thought I told you that. Oh, no. You don't want to get into the word of mouth stuff. Back to the flashlight example. So, and this is a real world example. This actually happened. A large gun manufacturer was looking for a portable light to mount on their rifle. And I can't tell you who it is. But they were looking for a portable light, and the idea was that when you go out in the field for a police officer or a soldier or whatever, if you have your flashlight and your gun, and I'm looking for somebody with my flashlight and I've got my gun, well, now what? I can't get to my walkie-talkie. It's difficult. So they said, well, why don't we just put the flashlight on the gun, and then you actually point the gun to look at people. great. And then, if you do need to shoot them, you're already lined up. So it works great. So they had all the type of things that we just talked about. They wanted it to be bright, and they wanted it to be light, and they wanted it to be reliable, and they wanted all those great things, right? All the requirements were met in this very large, very expensive program because it's mill standard. All of the requirements were met. But there was a problem. The problem was that LED lights were used. And there's something with the human eye, and people are only just starting to realize this, that people don't like LED lights. How many people have used an LED flashlight and gone, yeah, there's just something about the light that people just don't like the light from them. And it seems the reason is because the eye doesn't perceive contrast as well with LEDs. LEDs have a very narrow spectrum, and your eye doesn't like it very much. Your eye likes warmth, likes warm light. So what they actually did was they had a guy stand far away and another person with the gun flashlight thing. And the guy would pull out either a stick, a gun, or a doll, or as they put it, a baby. And the guy with the gun would see how long it took him to figure out what the guy had just pulled out. If you use a flashlight that has a normal everyday incandescent bulb that is just a cheap dollar store flashlight, you can pick it up like that. As soon as the guy pulls it out, you know what it is. Boom. You use an LED flashlight and you'll be standing there puzzling, trying to figure out what the heck he pulled out. But if you measure the intensity of that light, how far it goes, and all those other parameters, everything is the same. So it's a good example, and it's one that today is not solved. That problem exists today. Hard to address. So there needs to this has to go all the way back to fundamental research. What is it about the human eye that makes it difficult to figure out whether the guy's holding a stick, a gun, or a doll? Don't know. Wish I could work on it. So, the next bit is about treating failures like gold. And this is something that I preach a lot, both inside my company and out, especially when dealing with prototypes, especially when dealing with in university environments, is you build 10 or you build 5. And you go out there into the market, and there's always 1 or 2 that fail. And there's always this tendency to say, it's just a prototype. It's just a prototype. Demo-itis, you did a demo and it failed. There's always that tendency. The fact is that every failure, especially those early failures, that is gold. Because whatever it was that killed that product, if you trace it all the way to the root cause, sure, sometimes you're going to find out that it was because it was just a prototype. It was something to do with the way it was hand-assembled, somebody mis-soldering a wire. But surprisingly often, you'll find out that there's something fundamental in the design that you hadn't thought about. And if you just ignored it and said, it's just a prototype. It's an aberration. It's not a real failure. When you go to production and you do that first production run, that's when you're going to hit your 50% failure rate. Or even worse, you'll have a great yield until 6 months after you shipped, and then they'll start dropping like flies. So treat failures like gold. And again, as the managers of the company, you should make sure that anytime there's a failure, especially in those early units that you send out to your customers, to the field, to test the market, demand a report. From your own guys, from your own engineers, demand a report. I want to know the exact root cause. Don't tell me you're not sure, you can't figure out. Get to the root cause, try to find a way to repeat it. It will pay for itself again and again and again. And it'll surprise, even your engineers will come back and say, there was no way. There was no way that could have happened. Stuff fails in ways that you can't predict, and it always surprises you. The last part, I think, of the V is getting up into operations and maintenance. And again, this is very often for startups not considered very well. You've succeeded. You've got the product, you've built it, you've made some volume, you've got it out in your field. Well, now what? You've got a company now, you've got day-to-day operations, you've got product in the field, you've got customers who are going to call, you've got potential failures, you've got people dropping them in their toilet, you've got dogs chewing on them. How do you separate, the real failures from the failures where people just don't understand it? Good example is no fault found. Pretty much across the board, when you have products returned, about 70% of the time, on average, it's a no fault found situation. The customer returned it. Maybe they just didn't want it. Maybe they didn't understand how to use it. 70% of the time, there will be no fault. So how do you handle that? Sure, you thought the product was indestructible. Maybe it was. You're still going to have failures. So understanding ahead of time how you're going to handle that, how your organization is set up for it is very key. Otherwise, you're going to trip all over yourself when you get that first big order. Those verification documents you did, hugely helpful. Because when that product comes in the door and you don't know what's wrong with it, you say, hey, you know what? Run it through the verification test. That test where we went through all those little tiny things, run it through that. Let's find out if it meets everything still. And sometimes you'll be surprised and you'll find out that there actually was some little thing that went wrong and the customer noticed it, but your engineers didn't. Because they were looking at a production level, not at the design level. That test plan is also useful if you decide to outsource. And dealing with customer support, depending on the volumes you're going to, if you're not quite prepared to just jump your company into something huge to handle huge volume, there are companies out there that do nothing but customer support, and they're quite good at it. So if you're doing a steep deployment ramp, you may want to consider just outsourcing the whole support issue, and they'll handle sort of the tier 1, tier 2, the simple problems. And then if they get a problem that they just can't figure out, then it comes to you. So it cuts out that 70% of the no-fault founds are just gone, so your organization can stay small. Or try to plan a slower ramp. There's almost always friendly customers for any product. And find the friendly customers, set up your agreement with them, get them product first. Because they're the ones that, you know what, if it fails, they're going to say, yeah, come on into my office and try and troubleshoot it here, and they'll keep their mouth shut, which is really useful. Oh shit, yeah, okay, just don't tell the other customers about that. We'll fix it for you, and then we'll release it, and nobody will ever know. So find a friendly customer, ramp a little slower if you can. If you can't do that, you might want to consider outsourcing if it's a high volume product. And don't be afraid to go to the next revision. Budget for the next revision, and don't be afraid to go to the next revision. Don't be afraid to push it out a little bit. Don't be afraid to say, you know what, I have a Rev 1 and I can make some revenue from this. I'll get to Rev 2 eventually. I'm going to sell something that's, not quite perfect. Sell it, get some revenue, then go on to the next revision. It doesn't mean you failed, it just means you're paying attention to your customers and you're paying attention to your product and you're trying to improve. This is also a time to ask your customers what would they like to see in the next version. It's okay to have feature creep at this point. It's okay to dream a little. You can strip some of the stuff out, figure out which is the most important, figure out what's going to drive your market. The last part of the presentation, I'm going to talk about tools. This is really boring if you've seen these before, but it's surprising there's always quite a few people who haven't seen these before. So the first one is the Gantt chart. This is a just Microsoft project, or there's a whole bunch of other Gantt chart tools out there. Very straightforward. You can plug in your individual tasks, how long you think it's going to take to do them. These have just hundreds of different ways you can break stuff up. You can say that you have a certain duration for a task, as well as how much dollars it's going to cost, if there's tooling associated with it, how much percentage of a particular resource in your company. You can spend days and months doing these things. You can also track your progress as you go through. You interrelate tasks. When you set these up, then they're not that hard to set up, the basic ones. It's just you can go crazy on them. But when you first set them up, you'll be surprised how quickly it identifies areas of difficulty, how quickly it identifies what they call your critical path, but also your critical resource. If you've got your one engineer assigned to 18 different things that all have to happen at once, you pretty quickly realize that you need to outsource or find another engineer. So it's useful for tracking that type of thing as well. And when you get good at it, all of a sudden you start to find that you start to deliver on schedule, and you start to understand the budget. Amazing how often you'll do one of these up and you say, oh, I think this project's going to take us 3 months and $100,000. And you do this, and you start to realize all those little tiny things. Oh yeah, we have to travel to Montreal to do that. Oh, that's 3 extra days, right? I'm going to go there and get a hotel. And all of a sudden, you find out the true time and the true cost of your project. So it's very useful. And don't fool yourself when you're doing it. Be honest with yourself, and it'll pay for itself. Another project management strategy that I was going to touch on, I showed you the V model of development, which I think is good for most of this audience probably. But another one, and this is a little more military, is called the phase gate. And it's a little more staged in terms of the way you do an opportunity assessment, and then you have a gate. And these are really good as well if you're working with multiple companies, because the gate is a sign-off point before you can go to the next step. And usually these are done very hard stop. You do not move beyond that gate until you've got sign-off from all parties. So you do your opportunity assessment. You get everybody to sign off on it. You go past the gate, you move on, and you can see, planning, design, qualification, limited production, and full production. Each time a gate, and sometimes some reviews in the middle. So if you're doing a sort of a more military-style project, or a project with a lot of companies, you might want to consider this. You can also use a combination of the two. And again, search on the internet, product development tools, product planning tools. You'll find a myriad of them. Don't be afraid to use them. They're very handy. A little bit on budgeting. I've talked quite a bit about budgeting, about how much time it takes and how much money it takes. Don't forget to budget your resources. So pretty clearly you've got a budget for dollars. Not so clear as you've got a budget for resources. That is especially true when you have a technical resource running a company, because very quickly that technical resource, which may be you, if you came up with the product and you're designing the product, and you're also going to raise money for the company, then you're not going to develop the product. Raising money is a full-time activity today. Absolutely a full-time activity. And that goes for a lot of things. It goes for production, it goes for quality. Make sure that you've got the resources to properly execute. I sometimes talk about resource bankruptcy. Companies can go bankrupt because of lack of money. They can also go bankrupt because of lack of resources. I call that resource bankruptcy, and it's something to be very careful of. Make sure you have enough time. The second point from the bottom there, to find similar products. This is really handy and can be done surprisingly easily now in the days of the internet. You're trying to develop a product. It may not be exactly like anything else out there, but if you think about kind of the magnitude of the product, the scope of the product, maybe the customers it's approaching, you can quite often you can think of something similar. And if a public company has done that or focused on that other product, you can actually go online, download their books, and find out what was their R&D budget. What their R&D budget is probably pretty close to what your R&D budget should be if you're doing something of the same complexity. Sometimes you can even ask companies. I've done this. I've quoted a product to one company who's doing a product, and I know another company in the world doing a similar thing, and I've called them up and said, guys, I'm doing this. It's not competitive. I'm just curious. What did you guys end up spending on that? And quite often, if you talk to the right guy, they'll tell you. All of a sudden, you have a sanity check. Sometimes they're really good. Sometimes I've done that almost cold calling and had a person tell me, oh, but you know what really bit us? There was this standard that we didn't know about when we got into it, and that standard, did you know the testing for that standard is $50,000, and that you have to deliver 50 prototypes, which they destroy? And you go, oh, geez, I was going to build 10 prototypes. Now I find out I got to deliver 50 prototypes to be destroyed? Very useful. Look around, find similar stuff. Do some digging and you'll be surprised how quickly you realize that your estimates were off by an order of magnitude. Not always, but sometimes, especially if it's your first product. And don't expect to beat to beat all the expectations just because you're small. It really, sometimes, yes, maybe, especially if you're working for free, but it's tough. It's really tough to beat the expectations only because you're small. Big companies are really experienced. They're actually going to be efficient. And what you'll find is that it kind of balances off against each other. Sometimes it balances off against each other. Choosing a partner. And I don't think this is shameless self-promotion. When you look at the companies you want to do business with, think about doing business on a handshake. Think about what they've done in terms of, have you seen them in the market? What have you heard from other companies? What have you heard from friends? Look around. Investors are increasingly skeptical to just give out money to a group just because they've got a good team. They want to know, how are they going to execute on it? Are the partners that they've chosen also reliable? So look for a partner that will actually add to your credibility. If the company is credible that you're partnering with to develop the product, your VCs or your angels or whatever are going to look at you and say, oh, well, that's pretty cool. I got them signed up too. All of a sudden you can raise money easier because there's so many startups out there with great ideas and great marketing plans, and that's it. It ends there. So think about your partner. How does your partner add to your business? Don't just view them as somebody that you pay money to and you get a product design back from. It's more than that. Check their references, do a search, especially search in the news. Dig. The internet is great for that. And be totally open with the companies. There's a lot of slack can be cut when you're dealing with startups and something goes wrong. You know, maybe the startup runs out of money or they lose an investor or something like that. You know, if the startup and the company that's doing the work for them communicate, be honest, and things can always be worked out. It's better to be honest and to say up front if there's a problem. Sometimes the people who you're contracting to can actually help you out with the problem, as opposed to hiding it and going, oh crap, if I tell them I've lost my funding, they're going to dump us. No, tell them. They can very often help. And it never goes completely to plan anyway. So as I mentioned, businesses, anybody you do business with should be somebody you'd be willing to do business on a handshake. Don't do business on a handshake. But if you have that feeling like, you know, you want to go and take a shower after meeting the guy, probably you shouldn't do business with them. So, you know, you want to be willing to do business on a handshake because that shows a level of trust and a level of friendship, and you got to have that connection. A good approach, start with an MOU, a memorandum of understanding. If you go straight to like a huge 20-page contract, you're going to put in a lot of time and effort when you might find out that actually you're really far apart. So a little MOU, one-page bullet list. This is what we want. You know, this is what we expect from you. Do you agree? It will really quickly get you to the point where you can start working together, and then making the contract will be much easier. And in fact, you'll save on legal fees too, because if you hand a lawyer a set of bullet points and say, we've already agreed to these bullet points and here's the signatures, the legal agreement's easy. And you don't need a lawyer to do a memorandum of understanding because they're non-binding, right? But non-binding. And the contract will be referred back to, especially if there's any problems, you're going to be referring back to it, but you'll also be referring back to it even if things succeed. Because as soon as the product is wildly successful, everybody starts to ask, can I get more out of this? So make sure it's in place. I want to take a last look at the flashlight that we've designed. So yes, it's a mag light. And just to reiterate, not to underestimate the complexity of any product. Look at this thing. It's got 15 components on a flashlight. And those aren't even individual components. Some of those components have subcomponents. So don't underestimate. Think about it. Break it down in your mind. Break it down in your documentation. Effectively, every single little part of this is its own mini product. Every single part of this has its own little design spec, its own, you got to find a manufacturer for it. You got to find a way to test it. You got to make sure the quality is proper coming in. You don't have to be scared of it, but you want to make sure you're managing it properly. And the best way to manage it is with a good, clear documentation set. It'll keep everybody working together, and it'll keep everybody friendly. Relationships fall apart when you start thinking about what did I say. So documentation, as boring as it is going to keep you out of trouble. And that's it. I see a few people yawning, not as many as last year, so maybe the flashlight thing helped. Are there any questions? Yes? Okay, so the question was, I mentioned friendly customers, and where would you go looking for friendly customers? That's a good question, actually. Oh boy, that's going to be really industry specific. Usually it's going to be the person who needs the product the most. So, for example, oh boy, I hate to use another military example, but I will. There was a project being done, it was a military vehicle, and there was a penalty of a few $1,000s for every pound overweight that vehicle was. And the vehicle was overweight. So they would be a really friendly customer, because they would be, if you could go to them and say, I have a way of reducing the weight of your vehicle, they are going to cut so much slack to you because you're helping to solve their problem, as opposed to going to somebody who's already got a vehicle that meets all the weight specs and saying, well, I'm going to save you gas. Right? So look for the person with the most pain. And also, I would say, look for the person who is second or third in their market. The top guy in the market is going to be arrogant. The guy in second or third place is going to be looking for competitive advantage. Those are more likely to be a friendly customer than the guy on the top. So look for the second place guy or the third place guy. Not the bottom guy, because he won't have any money. Yep.
If you've got investors,
Ah, yeah, good.
even if they're angels, you got your flashlight? Here, take it, use it.
Yeah, board of directors, angels,
Yeah, board.
excellent.
Yeah, we had an example in the fund I was with a company that developed basically a relay station for cell phones. And their labs were in a fairly small town. So he said, we were downtown Toronto, put it in the lobby of the building. Half an hour later, it was smoking. Quietly take it down, give it back to them. They hadn't anticipated what happens when it's bombarded by millions of phone calls trying to come through. Simple, quiet, fail with your friends sort of thing.
Smoking is bad. Any other questions? Yeah, oh, yes, somebody at the microphone. Oh,
Yeah, please
Okay.
use the microphones if you can so everyone can hear.
Yeah, I just want to. I see like product development. There's a pretty large learning curve involved, and I can imagine how doing it over and over like yourself, you'd get much better at the process, using the tools, using all the different processes that you use. So I'm wondering. I'm just curious to know how entrepreneurial are product development companies becoming. Often you'll have a customer come to you with a problem and you'll design a product for them, but how often do you design your own products for your own entrepreneurial ventures?
for my company specifically, are you asking?
Well, how common is it in the industry?
I think to do what we do, this sort of co-development model where we like to partner with companies and work together, I think is pretty rare. I've been told by like VCs and stuff that it's actually very rare. You can quite often, if you're smaller and you go to a smaller product development company, you can quite often negotiate something where you can give them a piece and they'll do some development for you. But it's sometimes hard to find those guys. They are out there for sure, but it's kind of hard to find them. From what I've seen, a lot of them are cash is king, money on the barrelhead, and it's coin operated engineering, which is fine. That's their business model. Yeah. What you won't find, though, I don't think very often, is people willing to do it for nothing. It's just the economy is just too rough, and product development companies are not fundable companies, so they ultimately have to be funded by somebody, which is you. Usually, the best you can hope for is to get a partner, somebody who's going to help you raise money, or somebody who's going to go to bat for you.
Cool. Thank you.
Okay. Does that answer your question? You still look like you got a bit more in there, but you okay?
Yeah, I'm good.
All right. All right. Over here.
You mentioned that fundraising is a full-time job. What exactly Do you understand by that? What are the activities involved? How to do them well?
Okay, well, so this is this isn't a talk on fundraising. That's probably an entire talk in and of itself. And the reason is because fundraising is not just going and pitching to one person. Like just creating a good investor pitch should take a couple months. It really should. If you know, the bigger the opportunity, the longer it's going to take you. It's not just one page. So creating the investor pitch, pitching the investment, but also what about government sources? What about international sources? You know, there's just so much to do there to do it right and to get the best valuation. You can get money. You can get money fast, but you're going to give up a lot more for it. Okay?
Thanks.
Over here.
Hey Steve. Aaron Young.
Hi.
I'm with Young Minds Marketing. My question revolves around something you touched on in trust. So I don't know if the timelines are, but you'll be able to answer that. In your dealings with Research in Motion, with your experience with the product development, and another thing you touched on was honesty. So in terms of their securities, the backdating scandal that they did, their executives, can you touch on how maybe it is that you would deal with that from a product and development side? I mean, for instance, how aggressive would journalists have been if it were Nortel that was doing it, as opposed to like, you know, it being Canada's, you know, tech company, you know, it's Canada's baby, as opposed to if it were a company like Nortel?
Man, you're like, it's like right over my head. I know very little about that. The backdating scandal was like 3 or 4 years after I left RIM, so I've been out of RIM for 7 years. I don't even know how to answer that one, to tell you the truth. I'm sorry, I don't.
And another thing I was going to touch on, and it's a little unrelated to everything in terms of yourself, but
okay.
I noticed the attendance sheet outside. I think everyone is sort of a forward thinker in here, and I saw that a bunch of them were scattered, and somebody on the attendance sheet just put their name, which on one sheet that had been filled out by nobody else, but they just put their name down. Perhaps that's not the most green initiative, but that's unrelated. Thank you.
Okay.
I guess he doesn't like it either.
Yeah.
My name is Rupa. I work for an IT software company, and what I wanted to ask you was, you had built RIM from the beginning, right? So there's a lot of lessons you probably learned in there from going from 12 to hundreds of people. And so can you give us some quick tips, or it's probably really hard to summarize this, but some tips you've learned to kind of speed up that growth, or some of the things, the key things you learned, so that you could kind of like leverage that and grow into something huge?
Sure, I can try. So I guess there was a few philosophies that we had, and I mean, quite a few of them need money is the problem. But we had quite a few different philosophies that we tried to follow, and I say we because it was a huge team effort, and the overtime put in by that initial team of 12 building it to thousands was unbelievable. There were cars in the parking lot every weekend. Harder to do now. The mentality is changing of the newer generations, but a couple things. One of them was, if somebody good comes through the door, hire them, get them on the team.
So even if there's no role for them, you'll find something for them.
When an A-grade player comes in and you kind of know them when they come in, find something for them. They'll often find their own job within your company. So, you know, that's something that I've always done, is just if somebody good comes through the door, I hire them and worry about a position later. And I always make sure that I have the right equipment. The failure because of not having the right equipment is really sad, and it should not be an excuse ever. So,
what do you mean by equipment? I don't understand.
like, well, for example, you know, I've gone into labs where people are developing, you know, high-speed, you know, say high-speed optical stuff, and you look at their equipment, and it's like, you know, 20-year-old equipment because they got it at a university surplus sale. You know, your guys are going to be so hobbled by that. We bought a little module, for example, for analyzing a communication path, and this module was about $10,000. we brought it in, and an engineer, one of our engineers said he had been working 3 weeks trying to solve a problem. He hooked this thing up, plugged it in, and it told him in about 5 minutes what his problem was. Well, you can't even quantify the savings on that of getting to market potentially 3 weeks earlier, because this silly little thing could just go out and analyze, millions and millions of pieces of data flowing across a bus and say, oh, there's the bad one, which is literally what it did. So the right equipment is definitely important. But I don't know, I mean, those are really kind of, yeah, it's, it's a tough one. Sure.
Hi there, I guess I'm next. It's Charlie Mack here from Braino Vision. Steve, I'm just wondering, it sounds like you have an awful lot of experience dealing with boards and dealing with teams building products. I mean, obviously that's why you're here. I'm a big believer in trying to catch things early. And I imagine you have a lot of experience when people are starting to not really work together quite as well as they should. And I'm wondering, what are some key early warning signs that you could recognize when perhaps a board or a team, as you mentioned earlier, they're trying to think about what they said as opposed to perhaps moving forward with the project? Is that clear? Or?
Oh yeah, that's clear.
Okay. Tell me what you can tell me about that.
Wow. Well, yeah, I've had those problems.
Not to put you on the spot or anything like that.
Yeah, no, I think one thing that I have learned in having those problems is I'm getting more careful about checking references. I always used to worry about hurting people's feelings by checking references, and I'm I guess becoming a lot harder about that. I used to tend to believe what people would tell me at face value, especially about themselves and especially about their experience, and I've just been burned way too many times with that. So now, it's not that I don't believe you, right? It's that if somebody comes to me and they make certain claims or whatever, if I can find a way, and sometimes I have to ask them directly, I want to follow up on references. And references, you can read between the lines a lot. If you start asking somebody questions and you can hear that evasiveness in their voice, because you're not really allowed to give a bad reference, but you hear that evasiveness, or surprisingly, sometimes I've done internet searches on people and oh my God, like I had one guy I was going to hire and I found out that he was wanted in the States for like alimony support and had abandoned his wife and kids, and it's like, man, the more, the guy presented, he was such a nice guy. And if I would have hired this guy, I don't know, it would have been terrible to the team. So now that's a really obvious one. They're not always that obvious.
But it sounds like you're really concerned about guarding the team as well, right?
Yeah, I'm very protective of the team. Okay. Yeah.
Thanks.
Yep.
Hi, I come from a product development background, and I just thought you portrayed the design phase as a very discrete part of the product development process. And I think for people in here, if they have not developed products before, or if it's a new product, a new field they haven't been into before, and you're outsourcing your development team, your engineers, your industrial designers, it might be a good idea to potentially bring them in earlier, because potentially they have actually worked on a similar project. And for instance, in your flashlight example with the LEDs, perhaps they would have known that the eye only saw glare in low contrast situations a certain way. They had worked on a project 3 years ago and could offer you that at the beginning and save you that really costly mistake down the road.
Yeah, that's a really good point. Certainly having the team together as early as possible is a really great idea. What I was trying to stress, I guess, was don't start the design. You should still have the designers involved, have the team involved absolutely as early as possible. Even the subcontractors, if you can, get the subcontractors involved early, because they'll sometimes tell you, the best way to do something. Just try to avoid starting the design until you know what the heck you're designing. Okay? Yep.
I see. So a fairly popular, process right now is the Scrum process for software development. And I'm a software developer myself, so I was wondering if you had any comments, because a lot of the presentation that you were presenting was mostly hard products, whereas software I tend to, sometimes it's very difficult because you can customize it so much, and each customer is different sometimes. So.
Yeah, and I am a hardware guy. I'm sorry.
All right, no problem. Thank you.
But that's what I meant about the tools, right? Like, look up the tools. There's a lot of good ones. Yeah. Even so, I don't know much about the Scrum process, but you know, that probably cuts out the bottom couple layers of the V, but it
So
doesn't
it's actually
necessarily do the.
iterative, right?
Is it?
Yeah, so it's like requirement, build, show customer, and then come back. So it's a very iterative loop where it's like baby steps every step along the way.
Okay.
Yeah.
Yeah, sounds neat. I'm going to look that up myself.
All right, no problem.
Oh, very cool.
Hi,
Yeah.
Steve. Thanks for doing this tonight. I've been on the product development side from the marketing finance side, and we used a stage gate process, it's a version of the phase gate. And at the beginning, we would do an ideation and get our estimates from the various functional areas and cross-functional teams. And ultimately, the IT teams would never give us a good estimate because they would always say, you know,
They didn't inflate it.
yeah, there's going to be things we can't possibly think about. So could you speak a little bit about your experience in I guess, trying to ballpark these budgets and resources and how you dealt with the relationships?
Yeah, I've had the exact same experiences. Software guys, the IT guys, they are the hardest to pin down for an estimate, right? And I think part of that is because every product goes out with bugs. And software bugs are the thing that everybody knows, they're always there, right? So how do you budget for killing a software bug? You just can't. So that's why I was suggesting that try to find similar projects from other companies and try and find out what they spent. I haven't found a much better way than that other than just getting to know your team. And if it's your first project with that team, you just don't have that option. You just don't know. So look for a similar project, find out how long that took. If you can, find out what the history of your team is, and that's sometimes you can do that in the reference checks. And I've asked that question before in reference checks. I've said, you know, when I almost said his name, you know, when so-and-so would give you an estimate, how accurate was he? And I was surprised how often the managers would immediately give me a multiplication factor. Oh, he's about 3.5. Oh, great. Funny how, like, just perfect, you know. Or sometimes 0.5, you know, but usually it's more the other way. 3.5, whatever he gives you, you know, really it's 3.5. Okay.
Steve, I got a question. It actually builds on the software issue, but I think also true hardware. My old chairman used to say, better is the worst enemy of good. Do you involve the sales team in to say enough, you know, feature creep? To this point, my experience with software developers is they never want to stop adding yet another feature. And is the sales group, I mean, do you rely on them to say, I can sell that, stop, you know, leave something for version 2, just don't keep going? I mean, do you involve them in the team?
Well, they're involved in the team in the sense that they're coming up with that customer spec, and they actually are involved in the product validation spec, so that, you know, the software team or the whole team, when you meet the spec, you're done, you know. So from that point of view, yeah, they're definitely involved in it and definitely breathing down our necks, saying, when can we ship? When can we ship? When can we ship? So yes, I involve them both in the specification writing and at the very end, looking over when the validation's done. Yes.
Hi, Steve. I was wondering if you could touch on your experience working with contract manufacturers in Asia, and more specifically, the pros and cons of doing as much in-house or local development in Canada and splitting up the process and taking the final manufacturing perhaps to an Asian contract manufacturer versus starting the process from the beginning in Asia with the partner you ultimately thinking of will do the, you know, the final mass production.
Sure, yeah. I've had quite a lot of experience taking products, both doing them in-house, doing them subcontract in Canada, as well as taking them overseas to a variety of countries, not just the China, which most people think of first. You gotta have the volume. it's really, you've got to have the volume, and my experience has been that prototyping is extremely difficult in China. Getting those first prototypes done is extremely difficult because there's just not, you don't have enough interchange. You pretty much, in the early days, you have to be willing to go there and camp there. So if your product volume or the margins you're making does not provide enough funding for you or someone you really, really trust, not the subcontractor, you or somebody in your company needs to be in China. And you might be there 3 months, 4 months, 5 months. It's got to be big. In my opinion, it's got to be big.
Now, have you ever done that on behalf of a client? Like somebody's hired you?
Oh, yeah.
You do that?
Yep.
Okay.
Yeah, we've done that. And we've done the transition as well, where we start off and we manufacture 200 or 300 of something in-house, and then we transition it to a Canadian CM and we make thousands, and then we transition it to a Chinese CM and we make hundreds of thousands. That works well. Because what happens is when you make it in-house, or in-house could also be a local CM, a friendly CM, right? You figure out your yields, you figure out the best way to test it, you maybe even come up with your first test cell. You get the feedback into the design. Again, that idea of if it's in China and those guys when they make it, they're going to just blast out 10,000 of them. And they may blast out 10,000 of something that doesn't work. You have it done locally, you're actually there, you're looking over their shoulder, and you're feeding it back into the design right away. Oh, look, they found that part really hard. When they were threading that on, it was really hard. Let's make that easier for them. Or reprogramming took too long or whatever. By the time then you go to China, you're able to say, here's my product, here's my BOM cost, it takes us 7.2 minutes to build it, and we have a yield of 98%. You go to China and you don't say, how much will this cost to build? You go to China and you say, I will give you this much for building it. It's very powerful. You'll make way more money.
That's great. Thank you.
Okay.
Hi, Steve.
Hi.
By the way, I own that flashlight, and I have some problems with the thread. Okay.
Did you know it had a spare bulb?
I think I find it.
Yeah.
Okay. So, back to my question. When you build your team, how important is to have some very creative, imaginative person versus some other team members who are like over-analytical? Let's say they just pick one product and they just over-analyze it, and they just, and that's how they come to some success. And the other question is like how you deal with the copycats. Let's say there are some highly specialized companies, let's say in the United States, who are just copying your product and they just put it on the market, perhaps in China. So.
Okay, so the first question about team composition, if you can afford it, definitely a mix is really good, and not just a mix of attitude. There are people who they just love to come to work 9 to 5, put down their head and focus on one thing. Those guys are great. You need them, but not as much creativity there. And you need the creative guy, but boy, don't expect that creative guy to actually turn out something that works. So if you can afford it, get a mix. If you can't afford it, oh man, it's going to depend on the product, which way you go, which one you go for. And maybe you can find somebody a little bit in the middle. So that's part of it, okay? Again, identify your operations, identify what you want to be good at. If what you want to be good at is that inventive part, then subcontract out the bit where the guy actually puts his head down and does it. Okay? But also consider your mix from the point of view of the quality of the player. Think about, you have A players and B players and C players, and you do need a mix of those, because your A guys are going to get real bored if you have them doing C guy stuff. So you need to mix it up both in terms of the quality of the player and the personality of the player. The next question was about copycats. That is a whole presentation in itself. Copycats are difficult. I love patents. I'm big on patents. But patents are only worth what you're willing to put behind them when it comes time to sue somebody. Which sadly for a lot of startups isn't much. And the copycats, especially if they're big ones, they know that your pockets are shallow. So your best bet is to hit the market fast and hard. And that's where, again, the friendly customer I brought up before is really helpful, because you can go into your friendly customer, you can try some stuff out kind of quiet, keep the feedback quiet, so that by the time you hit the market, you can hit it really hard and really fast and get that jump so that you become the de facto standard before the other guy has a chance to copy you. Okay? Thanks.